right.
Now,
Now,
talking about point and interval estimate. Alright, let's go back and actually start looking at point estimate. We got point estimate is actually from a single sample. From the census, we took a single sample out and we use it as a point estimate, right? What we're going to do is look at some interval estimate. So what today we need to know is think about what is the population parameters and examine context, where sample proportions can be used a point estimate of as a point estimate population or proportion, understand the reliability of point estimates, and define and discuss the use of interval estimates for population proportion. All right. So we know that from our central limit theorem, for sufficiently large number, n is greater than or equal to 30, and p is approximately 0.5, then the sampling distribution of sample proportion for repeated randomly taken from a proportion is approximately normally distributed. So we can say that p hat is normally distributed with the expected value of p, and this is how you calculate the variance. All right. Alternatively, we can use np greater than or equal to 10 and n into 1 minus p greater to 10 to determine if we can approximate the sample distribution as normal distribution. Just note that we're going to use 10. I've uploaded Nelson for you, and Nelson used 5, but we know we're going to use 10 and not the as in Nelson. All right? Just make sure that you know it's 10. Now, so let's talk about standard normal distribution. You know that we can work out the z-score, right? Z-score is actually, if you're not talking about p hat, is the value you obtain, take away the mean, and then divide by the standard deviation. All right? So we can do the same thing for p hat as well. We can work out z-score if we know that p is there. All right, if we know the population p, we can work out z equals to p hat take away p over the standard deviation. Now, if p is unknown, then we will require a sample proportion p hat 1 to be used as point estimate for p. So if we don't know p, we're just going to use p hat 1. All right, one of the sample proportion to be used as a point estimate. So you should be able to see that with the normal distribution, we can actually, of p hat, we can actually make it into a standard normal distribution. All right, now let's try an example. Example 1. Repeated random samples of size 210 are taken from a population with p equal to 0.46. Now, you're given p, which is 0.46. To form sampling distribution of a sample proportion p hat. Give one reason why it is appropriate to model p hat using an appropriate approximate normal distribution. So what you could do, all right, let's read the second part first. Hence determine the number of standard deviations that a sample proportion of 0.5 is from the true population proportion. All right, you know that the size is 210.
yeah.
And we talk about the minimum is about 30. So what we could say, and 0.46 is close enough to 0.5. So we can say that p is approximately 0.5, and the sample size of 210 is sufficiently large. Right? So therefore the distribution will be fairly symmetrical, and an approximate normal distribution is appropriate. So think about it that way. What is p? And what is sample size? When it's fairly large, sufficiently large. Use the word sufficiently large when you're answering a question like this. All right? So you could work out, I was drawing that. So what you could do is work out the expected value of p. Expected value of p hat is 0.46. That's all. All right? And then you can definitely work out standard deviation of p hat. Yeah, if you're given decimal, you've got to use decimal. This. And then you can work out what the z-score is. Alright? Once you can work out the z-score, you know that, therefore, because it's negative, it is the sample population of 0.5 is 0.29 standard deviation below the population proportion. Yep.
Wait, isn't it 0.46 times 0.54 for the z-score?
Oh, did I say 5.5? It is
yeah, or 4.5 and 5.5.
4.5 and
Because you have
that's
one take away 0.45.
but you have you have the true mean of the population, right?
Yeah, so it's one take away point. Oh, shoot, what did I write? It's
Yeah.
0.46. Yeah, my fault.
46.
It's not 0.45, it's 0.46. Ah, yep, it's 0.46. My fault. I'm going to change that. That's 0.46. That's correct. You got a mean of it's yep. I'll change that. I think my calculation is incorrect as well. Yep. It's 0.46 and 0.54. Yep, my fault.
The other one as well, or not?
Yeah, the other one as well. That's the same thing. Yeah, I'm going to change that. I'll change that later. It's my fault.
And what's the actual answer?
Yeah. Yeah, it's my fault. The calculation could be correct, but I'm not sure. Check my calculation.
It is correct, actually.
The calculation is correct, but it written it incorrectly. My fault. It's 0.46 and 0.54. So I actually typed in the calculator correctly.
No, it's
But
in school.
writing
so
down
how
is
many
not right.
standard deviations away is it?
So you got to say that because it's negative, say that it is below the population proportion P. All right, say it's below. Now let's have a look at example 2. Example 2 for the appropriate normal distribution of P hat.
No.
Normally distributed as 0.39 and variance of 0.002379. Determine the sample size n. And then the value of k such that probability of z. So here you know that we are going to look at the standard normal distribution, and this is the p hat. That distribution from there, normal, correct to 4 decimal places. And the value of p hat that corresponds to the value of k such that p z greater than or equals to k equals to 0.01. Correct to 2 decimal places. So read the question carefully. I got a feeling that when I answered the question, I may not have read the question carefully. Okay. So you could use this 0.39 times 1 minus 0.39, which is 0.61 divided by n, will give you the variance. So that is what you should use, and you can work out n is actually 100 nicely. Now, the value of k such that b z less than k is equal to p probability of p hat greater than 0.4. Now, how could you do that? For me, if I do anything like this, I would actually draw it out first. Alright, I draw the first bit. I know that this is 0.39. Alright, this is 0.4. So probability of p hat is just the area here. Now, what does normal distribution tell us? What does normal distribution tell us? What does normal distribution tell us? Hey? Come on! What's the property of the normal distribution? Yes, it is symmetrical. So therefore, I use a different color by symmetry, or you can sketch out another graph. By symmetry, you know that the area of this has to be same of the area as that, right? Yeah, because that is the same as that. I'm not looking at k yet, all right? I'm just looking at what this value could be, and then change it to k, right? Yeah. So that would be, if this is 0.39, 0.4, that would be 0.38. All right. So, oops. So that's 0.38. So you got to use the idea of normal distribution, which is symmetrical. then both areas are the same, and then you can work out what k is. And you know that it's going to be minus because it is below the mean. So we're only looking at this sort of situation at the moment, all right? We're talking about the probability, using the probability and using your ideal normal distribution to work out all these values. And the part C, the value of p hat that corresponds to the value of k, such that probability of z greater than or equals to k equals to 0.01. All right? So greater than or equals to k equals to 0.01 is this little bit here. So you have to use your calculator. Remember how to use it? Yeah? You need to use your calculator to find out your k. So it's the right tail, it's from k to infinity. Alright? The value of k to infinity. So you could work out k. Once you work out k, you should be able to work out what p hat is. Alright? P hat take away p1. This time we're going to use 0.39. So therefore 0.50 I would say. 2 decimal places 0.50. I'm just telling myself, I think I've not read the question carefully. 0.50. All right, happy for me to move on?
Because that's the amount.
Because that's the variance. Wait, what?
All right, next.
And the middle is
Now,
0.39.
we're going to look at probability interval estimates.
The middle. Oh, the middle. Yeah,
I mean, you got to think about it. We are looking at just a probability. All right. Think about what we're trying to do is estimating the probability in between intervals. So we can think about it as the 68, 95, and 99.7% rule. All right. Since we know that this is the variance, what you could think about the 68% rule, which is the mean plus 1 standard deviation. This is 1 standard deviation, right?
Yeah.
Because the square root of that, that's 1 standard deviation. This will be 2 times that, 2 standard deviation, 3 times that, 3 standard deviation. Yeah? Now, you got to really think about this as, although you got a sort of slightly, in inverted commas, complicated formulas, that is actually just a standard deviation. You're working out the standard deviation. Go back to your normal distribution, start thinking about mu and sigma. Mu and sigma. And some of you actually did mixed up mu and sigma in the investigation.
Looking at me. Wait.
I don't know, I'm not saying who it is, but yes, it was.
Caleb, bro, come
It
on.
was. Yeah, you got to try to make sure that you know what is mu, which one is sigma. So expected value is mu, or the mean, and sigma is, in this case, is p, 1 minus p over p. Alright? Just use a diagram, just to make it a little bit clearer, so you know between the mean and 1 standard deviation, 68%, 2 standard deviation, and 3 standard deviation. Alright? Just make it a little bit clearer, that's all. Alright, so now here you can think about for any z scores now. So for any z score, p hat is in between the interval of the mean plus that plus the standard deviation, z times the standard deviation. I mean, Club uses the word probability interval estimate, what you really need to think about is we are only working at the probability. Yep.
So this is only for the normal distribution of like
The p hat and p, the sample distribution.
the real one, not an estimate of it.
You could be use you could use estimate as well.
Okay.
Point estimate. You could use the out point estimate and expand it to the population and use it as the next example. I'll show you that.
Yeah.
Alright.
Okay.
So now, not next example or the example 4. One of them I've got one of the example. I think it's example 4. Yep, example 4 is when we are looking at the point estimate. So here we've got a census. So the census shows that 62% of the household still have a functioning landline. For a random sample of 400 households, determine the value of k such that whatever. All right, now we are looking using the probability to find those two values. And then we need to interpret the result in context of the question. All right, we know this is a census. We know the p.
Yeah.
Yeah, we know the p. So what we need to do is write out first. P hat is normally distributed 0.62 and 0.62 times 38 over 400. That's the variance. All right, that is the what we can use 400. All right. We need to think about how we could derive p hat. Use p. You know that, so you can work p times 1 minus p divided by n, which is for this for the random sample of 400 households. All right. So there, draw it out. So you know what p is, p minus k and p plus k. I wrote down p because you know that the expected value of p hat is p. Yeah?
Yeah.
All right. So therefore this is p and then p minus k, p plus k. And using your calculator, do you know how to use this? Can you remember how to do that? Now, I'm going to show you again, all right? Let me write this down so that I can remember. P
Centered, yeah.
hat and 0.62, 0.38 over 400. Now, all right, let's get your class pad, please. Do you have a class pad? Who hasn't got a class pad? Everyone got a class pad? Grab your class pad out, please. You have one? All right. What I want all of you to do is be able to use the statistics. Here, I'll show you why. In this case, you should be using statistics. Where's my...
Where's the answer?
All right. Now, go to...
Was it 0.5?
If you use main, I'll show you why you shouldn't be using main. So if you use main, if you go to interactive distribution,
So it only gives you one.
yeah, it only gives you one value, which is inverse
K equals that, but
normal
I'm
CDF.
right.
So you know you want it to be centered. Probability is, what was it? Point, sorry, 0.9.
Yep.
And then sigma is, now, instead of working that out, you could do it this way. 0.62 times 0.38 divided by 400 to the power of 0.5. You can just type the whole thing in instead of calculating, and then that's 400. That's 0.62.
0.58.
Yeah.
0.62. All right. If you do it this way, you only get
0.5,
the
which is
Square root.
the square root.
the p minus k value. So if you actually go to whatever you call it, go to
Yeah, the K's on that.
statistics.
Yeah, I know.
If you use statistics and do calc,
That's
inverse
still
distribution, inverse normal CD, like I say, I normally like to type in help so that you know what the description is. And then next, center, it is center because we're not talking left, right, or right. The probability is 0.9, 90%. And sigma is again type in,
Same thing.
yeah, 0.62 times 0.38 divided by 400. Remember, to the power of 0.5, all right? And that would be 0.62.
Yeah, but
Next.
then you got to solve K.
Yeah.
Got two
And
out
then,
using the
now,
lowest law
the
values.
one good idea is to draw it.
P
And
is
so that you know what
P minus K equals that.
what those two numbers are. 0.58 and 0.65. I like to do it this way so that I can actually see the graph.
It's below the mean.
Yeah, I actually see the graph. Then you know for sure that it is the center,
What he's doing, and then you can get
just
like
in case you make a mistake.
That's
So here, K is approximately 0.04. Alright? So interpreting the results in the context. So in the context, there is a 90% chance that the sample proportion
Yes.
is between
You can
0.58
check
and
that because
0.66.
This is lower than the
So
mean.
what we're doing
Lower than
is
0.66.
using one. Alright, one number, the P we know exactly.
That's the lower bound there.
But we use random samples of 400 household.
Yeah.
So for any random
P-
sample
P
of 400 household,
Yeah.
the sample proportion could be between 90% of the chance is between 0.58 and 0.66.
Yep.
Alright? Yeah. Although we say that this is for random, but it's actually for all the random sample of 400.
Right.
Alright? So the range is 0.58 to 0.66. So you can see that that's the interval estimates. This is talking about the probability of interval estimate. Right?
a good question.
So we know the probability, then we can find the interval. So 90% of the time, the sample proportion for 400 household, the sample proportion is 0.58 and 0.66.
No, 100.
90% of the time. Alright?
Bro, you shouldn't be able to get 100.
So what's going on here then?
I shouldn't.
No
Alright.
one should.
Okay, with that, thinking about that as a
There's a reason
probability.
why you can only get 99.95.
Now, here, so we know the situation of P, the value of P. But that situation, if P is not given, but instead we are given a random household of 400. And it's found that 239 has landline. So of course we can do P hat and find standard deviation of P hat as well. This time I'm going to use this information. P hat is 239 over 400. So the previous example, we know the exact P, and then we know the 90% based on the exact P. Right? The value, the sample proportion. This time, we don't know P. We are just using P hat. P hat is a point estimate. Using the point estimate, we are taking it to the lots of our 400
Yeah.
samples. Alright? So we can calculate the interval estimates. So here, when we are estimating variance and standard error, when the population proportion is unknown, then the point estimate for the variance is used. Alright? And the standard deviation of the sampling error of sample proportion, use a point estimate is referred to as a standard error. That's just a definition of standard error. Right. Last example. So example 4. For a random sample of 221 adults, it was found that 51 of them were migraine sufferers. Estimate the proportion of all adults that were migraine sufferers.
What a migraine.
Describe the sampling distribution of the sample, which is describing is just writing down this. Alright. Calculate the standard deviation of the sample distribution of sample distribution of sample proportions. Hence, estimate the probability that an adult is a migraine sufferer to within 1.6 standard deviation and a 99.7% symmetrical probability interval for adult migraine sufferers, and finally determine the value. Alright, so here, even though it did not say that it's symmetrical, it is symmetrical. You are looking at 1.6 below and above the mean. Right, of course, you can start off with looking at the mean. P hat. You've got to use P hat, right? All right. The other thing is, I'll suggest that as far as you can, use 4 decimal places. In the investigation, a lot of you gave probability to 2 decimal places. Right? We've been saying that 4 decimal places.
Do you lose marks if you do?
Of
One
course,
mark.
mate.
Oh,
I did force.
because the first 4 decimal
always
places I
do.
take 1 mark. I cannot penalize everyone for everything the following.
Yeah.
That's 1 mark penalized. The thing is, in Wade's exam, because examiners, we all have, whoever's marking has different questions, say they don't know what you've done previously, so they may take the marks off.
Oh yeah, true. Yeah.
So here it's pretty straightforward because we can do follow through, we know what's happening. But in Ways you can't do that.
Yeah.
I think. Alright, so you can work out P hat, which is something like this.
Oh, what's if you? Oh.
Which is there's a description. So P hat is normally distributed with mean of 0.2308 and variance of 0.00803. And then you can work out the standard deviation, which is that. Alright, so I drew this because I want to know. This is I use mu, could be p hat plus 1.6, p hat minus 1.6. But I just use this to indicate there's just a sketch for myself.
What should we
I
say?
know what I'm looking for. Alright?
Yeah, it should be yeah.
So therefore, I can work that out.
That should be square root. That should be square root.
Right? 0.8 and 04. Use your calculator.
0.00803.
Yeah.
No, because that's variance.
So it should be square root.
So it's
For
just
variance, yeah. But
0.2308 plus 1.6 times that. For this 0.2308 take away
If you want standard deviation,
1.6.
square root or not.
Yeah, so square root variance, yeah.
But in here, is that not?
and
Is that
it's the same for the
That's
next one.
variance, yeah.
The next one is if it is 99.7%, it's just minus 3 sigma and plus 3 sigma, that's all.
Right, so how is the left one bigger than the right one?
Which one? I've,
For the 99.7?
no, it's I wrote it the other way.
Yeah.
I wrote it the other way, should be 0.1458 to 0.3158. I worked out the plus 3 sigma first and then I worked out the minus 3 sigma. That's a typical mistake that I'll do in the exam. I've done that so often in the exam because I work out the plus and then I work out the minus.
Yeah.
So be careful, please. In the exam, be very careful. Please don't do mistake like this. That's Michael's mistake. Alright? And of course, finally, you can work out what your p hat is. Alright, I'll change it when I upload the PowerPoint.
Wait, how do
Alright. So, personally answering question like this, I will always draw. Alright? So, see, what happened is, now, you are using the probability to work out between, you are working out, for example, this, you are using the probability to work out between the mean take away 3 standard deviation and mean take away plus 3 standard deviation, which means it is telling me that we are using the standard proportion. The interval estimate between the standard proportion in there is between 0.1458 and 0.3158 for any sample proportion of the same size. All right. So in the census, you don't know how many people, but for the same size of the sample proportion, I can say that the interval estimate is between the interval estimate for the sample proportion for this size is 0.1458 to 0.3158. All right. Yep.
What's the value you've used for k equals in part E?
Sorry.
Where it says k equals negative 2.32, where have you got that number from?
Because this is
Normal
Z.
distribution.
This is standard normal distribution. Standard score. So from standard score, you got to change it back to your p hat. That's the standard score. So anything to do when you see the Z,
I don't understand.
that is the standard score. Z score already. So K here is 0.01%. You can work out, use your calculator what K is. All right, I'll show you. If you are not sure, let's go back. We are looking at tail. So if I go to my class pad, go back. I want the tail to be left tail. All right. Probability is 0.01. Was it?
Yeah.
0.01, and then this time, because it's standard score, sigma is 1, mu is 0, and then you got your answer. All right. And then again, you can draw if you want to. So you need to think about how to use your calculator, and then be able to interpret it. All right, I've finished the lesson. Oh, sorry, the last bit. Just a summary. This is actually from Nelson. The point estimate of a parameter is a single value obtained from a sample. The statistic used is called an estimator of the parameter. Whereas an interval estimate of a parameter is an interval that's likely to include the value of the parameter. All right, it's somewhere inside. Okay, let's stop here now. Exercises is from Nelson this time.